ready?
Are you ready?
Go.
All right, you can see that this is part of the kidney.
Use your other hand.
The brown,
Use your other hand.
the brown, I'll use both. Brown right here is the renal capsule, which is on top of the kidney itself. In general, you have the outer region, which is referred to as the cortical region. Then all of these individual triangular structures here, as well as these individual structures here, the interior of the kidney is referred to as the medulla. So you have the cortical region and medullary region of the kidney. You can see these individual arteries going into the cortical region, but you also see these individual arteries going into the medullary region. These pyramidal structures that you see right here are referred to as renal pyramids. In between the renal pyramids, this space right here is called a renal column. The renal pyramids contain nephrons in them. You can see in this one, for example, you have at least two. You have the renal corpuscle right here of one, and the renal corpuscle of another one. Both of these will merge into this structure right here, which is a collecting duct or collecting tubule. The collecting tubule, and there's several of them in each renal pyramid, they will all merge down into this rounded region called a renal papilla. The filtered material, the urine, will go into this structure right here. These structures are called minor calyces. You can see this better right here, a minor calus here and a minor calus here. They themselves will merge into a general area right here. That area is referred to as a major calus. So minor and major calus. All of the major caluses will merge into a general region called the renal pelvis. The renal pelvis will go exterior into a tubular structure right here called the ureter. The renal pelvis, the arteries and veins that you see here, the general region of going into and out of the kidney is called the renal hilus. Other structures will do the arteries and veins. You can see you have the renal vein right here, a renal artery right here. The renal artery will subdivide into several different segmental arteries. Then from the segmental arteries, we have the interlobar artery right here. This is the interlobar artery. There's also a lobar artery we don't see. It's cut and reflected here. I had to check on that. We go from interlobar to an arcuate, which forms this arch right here. From the arcuate, you have individual interlobulary arteries here. In the book, they're called cortical radiate. Now, if we see in this view right here, those cortical radiate or interlobular arteries will feed into the individual renal corpuscles of each and every nephron. Some of the nephrons that you see in this renal pyramid are juxtaglomerular and some are medullary. It depends on the loop of Henle, and this view doesn't show it quite well. We'll go to the next view. In the next view here, you can see the renal capsule on the outside. You can see the lighter tissue right here, which is part of the cortical region. Here is the arcuate artery and vein, and the triangular region right here is that renal pyramid that we discussed. You can also see is the renal corpuscle here that's cut and reflected. You're seeing a sagittal section of it. Here's another renal corpuscle here that's been cut and reflected. The reason why I wanted to show both of these is because you can see the proximal convoluted tubule here, the loop of Henle going downward, going upward, and then the distal convoluted tubule here. Same thing in this nephron, but it's a different nephron in the sense that you have the proximal convoluted tubule, but you can see how the loop of Henle goes all the way down into the medullary region, much further than the other. So this nephron would be considered medullary, whereas this one is considered juxtaglomerular. You can also see in this model that this interlobular artery feeds into a capillary net. That capillary net is called the glomerulus. The yellow that surrounds it, the cup-like structure, is called the Bowman's capsule. Collectively, it's called the renal corpuscle. Both the glomerulus and Bowman's capsule, again, make the renal corpuscle. You can see that both of the nephrons, in terms of the distal convoluted tubule, merge into this structure right here, which is the collecting duct or collecting tubule. It proceeds downward into this round area called the papilla. We'll go into the next section, which shows you this part, the renal corpuscle, we'll see in greater detail. This, I guess, model is the renal corpuscle in greater detail. You can see the simple squammal epithelium that makes up the Bowman's capsule. This section is the same as this section. However, what you're seeing on top are these little cells that wrap around the capillary branches. These cells are called podocytes because they have those little interdigitation, or it looks like little fingers or feet. That's why they're called podo. Podo means feet. Podocytes that wrap around the branches of the capillary bed. On this side, they show you without the podocytes. So collectively, this is called the glomerulus. It's the capillary bed. You can see right here, this is the efferent vessel going into the glomerulus. Then you can see, I'll move it a little bit, you can see going out, and that's, I'm sorry, I have to correct myself. This is the afferent going in and the efferent going away. What you can see is a cross-section of the afferent and a cross-section of the distal convoluted tubules. Together, the entire structure is the juxtaglomerular apparatus. The cells in here monitor all of the ions and water that's going into the capillary bed, and all of these cells here monitor what is leaving and going into the collecting tubule. These cells here are referred to as the macula densa cells. They're much longer, almost look like simple columnar cells, whereas these are more cuboidal in shape. What you can't see around both of these tubular structures are triangular cells called JG cells. The macula densa cells here make the renin that regulates the sodium reabsorption in the renal tubules. Alright, going downward to here, if you have the filtrate in here that's going to exit the body, or what is being filtered from the cardiovascular system, it has to go through the renal tubular network. It will go through this tube right here, and you'll notice these cells are simple cuboidal, whereas the ones in the Bowman's capsule are more simple squammal. The simple squammal cells allow for a lot of water to be reabsorbed immediately, whereas the simple cuboidal does have a high reabsorption, but just not as much reabsorption of water than the Bowman's capsule. You could barely see, but there's tons of indentations here, or finger-like projections. Those are microvilli that are on top of the cuboidal cells here. These cells represent the proximal convoluted tubule. The proximal convoluted tubule will go down. It will convolute, meaning it will twist and turn. It will become the loop of Henle, which evens out, and then the loop of Henle ascends and then convolutes again into the distal convoluted tubule, which leads into the collecting